To learn about fire alarm wiring and installation, consider these resources. Firstly, basic fire alarm wiring and installation provides foundational knowledge. Secondly, fire alarm systems design, installation, and maintenance by Robert J. Kopf and Patrick J. Fullen offers comprehensive coverage. Thirdly, fire alarm wiring guide by Thomas E. Short is a useful resource. Fourthly, fire alarm design manual by Michael S. Harper and Scott P. Doherty is available. Fifthly, fire alarm systems, a guide for contractors and installers by Fred D. Stickney and Joseph A. Diventi is also available. Sixthly, advanced fire alarm wiring and concepts delves into more complex topics. Seventhly, fire alarm systems, a comprehensive guide to design and implementation by Steve Cowan can be consulted. Eighthly, industrial fire alarm systems code compliance handbook by Roger A. Blades and Ken A. Budka addresses code-related aspects. Ninthly, fire alarm system design guide by the National Fire Protection Association, or NFPA, is essential. Tenthly, fire alarm signaling code, or NFPA 72 by the National Fire Protection Association, or NFPA, is also essential. For specific aspects, explore these. Firstly, fire alarm communication systems by Timothy L. Stinson. Secondly, mass notification systems by Gregory T. Alvarez and Douglas J. Daly. Thirdly, wireless technology for fire and security systems by William F. Rogers. Fourthly, maintenance and service of fire alarm systems by Daniel C. Hunt and Robert A. Clear. Additional resources include the National Fire Protection Association, or NFPA 72 National Fire Alarm and Signaling Code, Underwriters Laboratories, or OL, Standards for Fire Alarm Systems, International Building Code, or AUC, Chapter 9 Fire Safety Systems, Fire Alarm System Technicians Association, or FASTA, and the National Fire Sprinkler Association, or NFPA. When working with fire alarm systems, always adhere to the latest edition of NFPA 72, the National Fire Alarm and Signaling Code. This code provides comprehensive requirements for the application, installation, performance, inspection, testing, and maintenance of fire alarm and emergency communication systems. Understanding the different types of fire alarm systems is crucial. These include conventional, addressable, and wireless systems. Conventional systems use multiple initiating devices wired to a control panel. When one device is activated, the entire zone is indicated. Addressable systems, on the other hand, allow each device to have a unique address, enabling precise identification of the activated device. Wireless systems use radio frequency, or RF, signals to communicate between devices and the control panel. Each type has its own advantages and disadvantages depending on the application. Initiating devices are components that initiate an alarm signal. Common types include smoke detectors, heat detectors, manual pulse stations, and sprinkler water flow switches. Smoke detectors sense the presence of smoke particles. Heat detectors respond to temperature increases. Manual pulse stations allow occupants to manually activate the alarm system. Sprinkler water flow switches detect the flow of water in the sprinkler system, indicating a fire condition. Notification appliances are devices that alert occupants of a fire. These include horns, strobes, and speakers. Horns produce an audible sound. Strobes emit a visual flashing light. Speakers broadcast voice messages. The selection and placement of notification appliances must comply with audibility and visibility requirements to ensure effective alerting of all occupants, including those with disabilities. The Fire Alarm Control Panel, or FAP, is the central processing unit of the fire alarm system. It receives signals from initiating devices, processes the signals, and activates notification appliances. FAP also monitors the system for faults and troubles. The panel typically has a display and controls for system operation and annunciation. Wiring for fire alarm systems must be done in accordance with the National Electrical Code, or NEC, and NFPA 72. Conductors must be appropriately sized and protected to ensure reliable operation. Wiring methods must comply with requirements for fire resistance and mechanical protection. Conduit, cable trays, and other wiring supports must be properly installed. It is important to use the correct wire gauge for fire alarm circuits. The size of the wire depends on the current carrying capacity required for the circuit and the length of the wire run. Longer wire runs require larger gauge wires to minimize voltage drop. Voltage drop can affect the performance of initiating devices and notification appliances. Always consult the manufacturer's specifications and relevant codes for proper wire sizing. Fire alarm circuits are typically classified as either power limited or non-power limited. Power limited circuits are designed to limit the amount of current and voltage that can flow in the circuit, reducing the risk of electrical shock and fire. Non-power limited circuits do not have these limitations and require additional protection. NFPA 72 specifies the requirements for power limited and non-power limited circuits. Wiring pathways must be protected to ensure survivability during a fire. This can be achieved by using fire-rated cable, conduit, or other approved methods. The level of protection required depends on the type of system and the occupancy. Fire-rated cable and conduit are designed to withstand high temperatures for a specified period, allowing the fire alarm system to continue operating during a fire. Proper grounding is essential for fire alarm systems. Grounding provides a path for fault current to flow back to the source, minimizing the risk of electrical shock and equipment damage. The grounding system must comply with the National Electrical Code, or NEC, requirements for grounding and bonding. Bonding ensures that all metallic parts of the system are electrically connected, providing a low impedance path for fault current. Supervision is a critical aspect of fire alarm systems. Supervision involves monitoring the system for faults and troubles. When a fault or trouble is detected, the system activates a trouble signal alerting the building management. Common supervised circuits include initiating device circuits, notification appliance circuits, and power supply circuits. End-of-line resistors are used to supervise initiating device circuits and notification appliance circuits. A resistor is placed at the end of the circuit, and the control panel monitors the current flow through the circuit. If the circuit is broken or shorted, the current flow changes and the control panel activates a trouble signal. Power supplies for fire alarm systems must be reliable and have sufficient capacity to power the system during normal and emergency conditions. The power supply must be supervised to ensure that it is operating properly. Battery backup is required to provide power to the system during a power outage. The battery must have sufficient capacity to power the system for a specified period, typically 24 hours, followed by a period of alarm operation. Fire alarm system documentation is essential for proper maintenance and troubleshooting. Documentation should include system drawings, wiring diagrams, device locations, and testing records. The documentation should be kept up to date and readily available for authorized personnel. Testing and inspection are crucial for ensuring the reliability of fire alarm systems. NFPA 72 requires periodic testing and inspection of fire alarm systems. The frequency of testing and inspection depends on the type of system and the occupancy. Testing involves activating and initiating devices and verifying that the system responds properly. Inspection involves visually examining the system for damage and ensuring that all components are in good working order. Record keeping is an important part of fire alarm system maintenance. Records should be kept of all testing, inspection, and maintenance activities. The record should include the date of the activity, the name of the person performing the activity, and any findings or corrective actions taken. These records can be used to track the performance of the system and identify any potential problems. When troubleshooting fire alarm systems, it is important to have a systematic approach. Start by identifying the problem and gathering information. Review the system documentation and talk to building occupants to get a better understanding of the situation. Use a multimeter to test voltages and currents in the circuits. Check for loose connections, damaged wires, and faulty devices. Refer to the manufacturer's specifications and troubleshooting guides for assistance. Common problems with fire alarm systems include false alarms, trouble signals, and device failures. False alarms can be caused by a variety of factors, such as dust, insects, and environmental conditions. Trouble signals can be caused by open circuits, short circuits, and power supply problems. Device failures can be caused by age, wear and tear, and environmental factors. To prevent false alarms, keep the devices clean and free of dust and debris. Seal any openings that could allow insects to enter the devices. Adjust the sensitivity settings of the devices if necessary. To prevent trouble signals, ensure that all wiring connections are tight and secure. Protect the wiring from damage and environmental conditions. Regularly test the power supply and battery backup. To prevent device failures, replace devices that are nearing the end of their service life. Use high-quality devices that are designed for the specific application. Follow the manufacturer's recommendations for maintenance and testing. Understanding building codes and standards is essential for fire alarm system design and installation. The International Building Code, or IBC, and the National Fire Protection Association, or NFPA, codes provide requirements for fire safety systems. These codes cover topics such as fire alarm system design, installation, testing, and maintenance. It is important to stay up to date with the latest codes and standards to ensure compliance. Consider also the Americans with Disabilities Act, or ADA, which sets forth the requirements for accessibility in buildings and facilities. This includes requirements for the placement and audibility of notification appliances. The ADA requires that fire alarm systems provide both audible and visual alarms to ensure that all occupants, including those with disabilities, are alerted to a fire. Stay informed about new technologies and trends in fire alarm systems. Wireless fire alarm systems are becoming increasingly popular due to their ease of installation and flexibility. These systems use radio frequency, or RF, signals to communicate between devices and the control panel. Addressable fire alarm systems offer advanced features such as pinpointing the exact location of a fire and providing detailed system information. Voice evacuation systems provide clear and concise instructions to building occupants during a fire. Mass notification systems can be used to provide alerts for a variety of emergencies, such as severe weather, active shooter situations, and terrorist attacks. Remember that fire alarm systems are life safety systems and must be properly designed, installed, and maintained.